This episode on Texbusters, 6 textile students get together and create a new material. Having done research, they experiment and heat things up. The clock is ticking. What will they come up with? Is it a sweet, delicious fabric, or will they blow up the lab? Stay tuned for this mad experiment. These are Texbusters.
Well, Kenna, what are you making?
It's cotton candy. So sweet.
It has all these fiber-looking stuff. Almost suitable for
a textile material!
Okay guys, I think we have a potential to make a new material. A non-woven structure using this.
This is a cotton candy machine. It would be so cool if we can make a material out of it.
Sugar, I'm not sure that's a very good idea because it's a really unstable material. It's very susceptible to temperature change and moisture and a lot of other things. So maybe we should think of something else.
Yeah, but we could maybe replace the sugar with some sort of polymer and it would turn out pretty nice.
There's a lot of things that we could do with this machine. Definitely we should try out different materials.
Alright, let's get cooking.
This big round machine has a very interesting mechanism. The most important part of the machine, where all the exciting stuff happens, is the spinning drum. In the middle of this drum there's a heat source. On the sides there are small holes. When you put sugar in the small bowl in the middle, it starts to melt and spin through the holes by means of centrifugal force. The bowl catches the microfibers of sugar and you can pick it up with a stick. And that's how cotton candy is made.
We're here and we're ready to experiment with our cotton candy machine. We're not using sugar this time because that won't help. It dissolves. We coated the machine though because everything that we're going to use is thermoplastic and that otherwise if we don't coat it, it'll melt together. So here we are. We have some different products. We have ABS, nylon, PLA with bronze granulates, some elastic PVA, and thermoplastic granulates. And some other pellets, I don't know the name of, but we're gonna put it in the machine and we're gonna twist and turn and we're gonna make something beautiful. Keep watching. We're conducting our experiment in a ventilated chamber in order to prevent excess smoke from the cotton candy machine.
The team gets together to find out what the polymer will do to the machine. They want the fibers to stick to the wall of the machine to make cotton candy out of plastic. Will they succeed?
Trial, we're going to use a very small amount of granulates of ABS. Right now we're putting ABS in. We have tried spinning 3 different polymers. The first one we tried was the unnamed thermoplastic granules and it didn't work. It did not melt at all, so I think we have a problem with the melting point and the temperature of the machine. And the second one we tried was the ABS and it also did not work. It only melted inside the machine, but it did not manage to spin. And the final one we have was the protoplast and it did melt. We have a sample now. But the problem is the melting point is way too low for it to have a significant yield and most of the melted polymer just sticks to the machine. So yeah, that's all we have today.
In the small bowl they put different kinds of materials, but nothing good came out. What is going to be their next step?
Adam, what happened?
Yeah, we up the machine.
Now it's stuck in there. We cannot get it out. Okay, keep us.
Yeah, so guys, we have a little bit of a problem here. Nothing was extruded and we messed up the machine. Now all these polymers are sticking into it.
What's the problem? The polymers we worked with had a really high melting point. I think it's too high for the cotton candy machine.
Yeah, the melting point of sugar is like 80 degrees Celsius, but I don't see any problem in trying to increase the heat in the machine.
Is there any way to add heat to this machine without actually mechanically adjusting it?
I mean, we're trying to make this as simple as possible and energy efficient.
I have an idea. So, what if we cover the machine so the heat stays in, and as a result, we can spin away all the waste and clean the machine?
Sounds interesting. Let's see what it does.
The two Texbusters try out the new idea with covering the machine for a more efficient result. The fibers are not easy to catch now everything is covered, but they will see the outcome.
Right now the temperature in the machine is 233 degrees. That's definitely way higher than last time, so let's see what turns out. Oh look, something worked! So the fiber didn't extrude the same way it did on the cotton candy machine, but it did throw all the plastics within the extruder and onto the walls, so they all just cut into this little plastic thing. Well, this whole thing looks weird because it's a mix of random plastics we've previously used. But this is actually something unique and we can actually work with this further on.
Oh, these are cool.
Yeah, we tried to clean the machine from previous plastics and we got this as a result. A ring of plastics we previously used.
But are these virgin plastics?
Some of them, but we're trying to find a reused one.
Yeah, why don't we use 3D printing waste?
The 3D printer. What a glorious innovation. This machine allows the manufacturing process to create a physical object from a digital design. It has a lot of pros because it can create complex design and people can customize their own prints. But it has cons as well. It is a waste reducer and is a solution for the waste problem that we face. But it also produces waste when objects fail, for instance. Things get thrown away, but I think we have a solution for it.
The team starts all over again with shredding old pieces from the 3D printer PLA waste, since it is the most sustainable material. This time they make sure to retain the heat inside the machine by covering it with aluminum foil. Will this attempt finally turn out into the textile that they wanted?
I think it's a very interesting idea to reuse 3D printing material because there's so much waste when the machine stops. You can't finish your part, you have to throw it away. Failed objects are usually just thrown out and not really reused.
Okay, so we got all the stringy plastic material made from 3D printed waste, but what can we actually do with it?
Actually, we make this. So we made this box with LED light in it. I think this could be good for a decorative wall element.
Well, this is only one prototype, but I think that this is a breakthrough process and it really allows people to engage with their creativity while at the same time help reduce environmental impact. And all you need is 20 euros and a little bit of determination. The possibilities are endless.
How should we call it?
Well, it's a shade made of polymers.
Polyshades.
Oh my god, yes!
Well, I definitely see a lot of decorative potentials in this. I think with the correct manufacturing process, many things can be made from this. And actually, in the 3D printing industry, this is the closest thing we can get to a textile material. What do you think?
Yeah, true.